Thank you for joining us for the symposium. Our final keynote for the day is John Wolpert, a three-time entrepreneur and founder of the popular taxi app, Flywheel. Currently, though, he's known as the Director of Awesomeness at IBM while working as IBM's Watson evangelist. He seeks out awesome people, technology, and business opportunities. His mission is to build a giant wave of innovators that take Watson's cognitive computing services and use them to change the world. Prior to his current pursuits, Mr. Wolpert created new lines of business for several Fortune 100 companies, ran an international consortium of research labs, and ran IBM's fabled AlphaWorks organization and the Extreme Blue Incubator Lab, one of the most patented labs in IBM history. His work on collaborative business model innovation is published in Harvard Business Review and Harvard Business School Press, where you can look for it if you would like to read more. And now, here is the self-described shameless geeky dilettante himself, Mr. John Wolpert.
Hi, everybody. And that's a cautionary tale in letting people find your bio on the web. I think actually, I don't think they call me Director of Awesomeness, but I once referred to myself as Seeker of Awesomeness, and it's stuck. So apologies for that. It's great to be here. This is so exciting. I was blown away by, I had the pleasure of watching Rohit's presentation just a few minutes ago, and I've resolved to come next time and watch them all, or as many as I can, because that was amazing. And I want to talk to Rohit after this, in fact, if I can find him, because he's doing work that, in fact, quite remarkably, is stuff that he could be using Watson for. And that's mainly what I'm going to talk about today. I'm going to talk about Watson. I'm going to talk about some of the things that we did, but more importantly, I want to talk about what you can do with it. We spent a lot of time and effort right from the very beginning of Watson. I'll tell more about Watson in a second. With the idea that this isn't something that we just want to build and use ourselves or with our clients, but something that we want to give to the world to let everybody in this room do things that they couldn't do before for themselves. And that'll be my punchline at the end of this talk. So what is Watson? Has anybody not heard, any raise of hands, who doesn't know what Watson is or what has heard about what we did with Jeopardy and all that stuff? Yeah? Everybody's got that? So yeah, we famously won Jeopardy against the Grandmasters of Jeopardy, and that was a few years ago. And it was one of what we call one of our moonshots, or one of our grand challenges, was to be able to win at Jeopardy. Previous to that, a grand challenge was trying to win at chess, and we famously won at chess. In fact, when I was in grad school in the mid-90s against Garry Kasparov, and Gary went on to found a society of chess that combines humans and computer chess playing. And it turns out that every time you put a human and chess and computer team against either a human or a computer, the human computer team always wins. And we took that lesson and we said, you know what, let's build the next generation of computing around the idea that artificial intelligence, cognitive computing, was about extending the human capability and working together as a team. And talk about teams. Watson, the Watson organization, what Watson really is thousands of the most amazing, creative, scientific minds that you've ever met, working both in laboratories here and incubators all over the world for years, and I'm talking like 30 years. IBM spends $6 billion on research a year, $6 billion, and much of it now is devoted to cognitive computing and understanding both human language and human cognition. That's where we are focusing. That's our big bet. So the next, and so what Watson really is a bunch of people trying to solve that problem of how do we think and how can we create a class of computing that approaches the world more like the way we do, as opposed to the way we've been doing things up until now. Who writes code? Okay, so anybody writing code knows that basically up until now, computers have done 5 things. right? Can anybody, what are the five things that programming does? I'll start you off. Loops, right? We got loops. What have we got? Yep. If-thens, right? Conditionals. Assignment. What else? All right, I'll let you off the hook. This isn't Ferris Bueller. Five things. That's all we do. And you know, an amazing expansion of beautiful complexity that we can create. And now those five things are running this phone, right? Well, we're at the limit of that. Now we have to start to look at new ways of computing and bringing statistics and probability, matrix math, linear algebra. Rohit was right. Linear algebra, huge subject now that everybody hopefully is taking, into the core of the compute cycle, which we can do now because computers are fast enough and we can work in the cloud and we can economically apply computing to what used to be just way too complex, way too computationally expensive algorithms. Now we're taking those computationally expensive algorithms and applying them. And that's the foundation of cognitive computing, using probability in the compute. So you know, we kind of think like this. We observe, we interpret, we evaluate, we decide, and then we flow that back in and we do it again, right? There's a feedback loop. That's effectively what we want to do with cognitive computing. So with cognitive computing, Watson is observing, it's interpreting, it's evaluating the results, it's deciding, it's flowing that back in and learning again. So that's the basic loop at a very high level. I think listening to Rohit's talk, I'm going to step this up from basics to a little bit higher because you guys clearly can keep up, so I will. One of the examples of what we've done with Watson is help researchers identify genes that would have never been found, or were very difficult to be found in the scientific literature that, for example, affect colon cancer. So in a famous thing that we did last year with Baylor University, we took 23 million pages of Medline articles, fed them into Watson, into a specific Watson subsystem called Watson WDA, Watson Discovery Advisor, and discovered just by running co-occurrence and a whole bunch of algorithms, about 350 different operations, we discovered that there were 7 kinase targets. A kinase is in molecular biology, a kinase will phosphorylate other entities in the cell. And that phosphorylation process can sometimes really mess up what's going on, and you can lead to cancer. It's at a high level. I'm sure there's a couple people in this room that will correct me on that. But that work, for 30 years, kinase researchers have been looking for targets to find targets for colon cancer and other cancers. And in that 30 years, they found 30 kinase targets. Watson found 7 in a day. And it did that by analyzing all their previous work in natural language. They took 23 million articles, or 23 million pages of text, analyzed them, found relationships, made inferences, fed that back, relearned again, and through that process brought back hints and said, you ought to go and check out these 7 targets, because I think, effectively what it was saying is, I think this researcher, and this researcher over the past 30 years didn't know each other's work and didn't realize that this particular target was a likely candidate for cancer. That was amazing. It's just 7 right there in one go, where it usually on average is 1 a year. So that's the kind of work we like to do. I'm going to jump over some of this. So one of the other things that we've been doing is working on general cancer diagnoses. So for example, at Memorial Sloan Kettering and Mayo Clinic and MD Anderson, we've got a system there in those hospitals where oncologists can feed in a patient chart, and Watson will go to work and bring back a diagnosis. And as I said, it's not that Watson is, it's not like we're using cognitive computing on its own. It's the doctor and the system working together as a team. The diagnosis comes up, it actually suggests clinical trials, and it suggests a course of treatment. And then the doctor gets to say, yeah, Watson, you got it right, or no, Watson, you didn't get it right, or then he can make additional notes. And famously, I think now 2 years ago, at MD Anderson, a doctor was about to say, no, you got it wrong, Watson, and then went into the literature that Watson presented to back up its case. And it just happened that Watson had ingested a fairly recent set of articles and studies on that particular cancer, and determined, and the doctor went, oh, Watson, you were right. And it was because the doctor hadn't read that material. Clinicians in oncology have to read hundreds of pages of text every week to stay current. And this is a great help if Watson can say, hey, it's kind of like a chatty, the kid in the back of the class that always has their hands up. It's like Watson's like, I know the answer. And then the doctor can say yes or no. And in this case, the doctor, we won't say that we saved a life, but we certainly reduced pain and suffering for that patient because the course of treatment was something that doctor might not have otherwise used. I mean, that's amazing. So those are some of the applications of Watson. So how does it work? I'm going to throw up something real quick on how it works. See if this works.
Technology has helped us go further, go faster, go to the moon, solve problems previous generations couldn't imagine. But can technology think? Watson can. IBM Watson is a technology unlike any that's come before. Because rather than force humans to think like a computer, Watson interacts with humans on human terms. Watson can read and understand natural language, like the tweets, texts, articles, studies, and reports that make up as much as 80% of the data in the world. A simple internet search can't do that. When asked a question, Watson generates a hypothesis and comes up with both a response and a level of confidence. And then Watson shows you the steps it took to get to that response. In a way, Watson is reasoning. You don't program Watson, you work with Watson. And through your interaction with it, it learns, just like we do. Every experience you give it makes it smarter and faster. But in addition to learning, Watson can also teach. A new generation of doctors are helping Watson learn the language of medicine. In turn, Watson is helping teach doctors by providing possible treatment options. Watson is learning the language of finance to help investment advisors recommend the best way to plan for retirement. The IBM Watson Engagement Advisor can react to a caller's questions and help operators find the right answers faster. The IBM Watson Discovery Advisor helps researchers uncover patterns that are hiding in mountains of data and then share these new insights with colleagues. With Watson Analytics, you can ask Watson a question, and Watson can show you what the data means in a way that's easy for anyone to understand and share. The IBM Watson Developers Cloud offers software vendors and developers the technology and tools they need to take advantage of Watson's cognitive power. Accessible on the cloud, anytime. Watson needs you. This generation of problem solvers is going to learn much faster with Watson, and Watson in turn will learn much faster with us. Developers will solve new problems. Business leaders will ask bigger questions. And together, we'll do things generations before couldn't dream of. What will you do with Watson?
So I have one problem with that video. It talks about Watson in the singular, and this is, people have given me lots of speculation on why we call this thing Watson. Does anybody know? Okay, well, I'll tell you the speculation. Some people think it's because Watson is Siri's boyfriend. Some people think that Watson was a question, that maybe Watson was a question in the original Jeopardy show about Sherlock Holmes. No, it's actually that T.J. Watson was one of our founding. So you have Elon Musk and folks like that today. Well, T.J. Watson was the Elon Musk of his day. In a way, if Elon has been characterized as Tony Stark or Iron Man, T.J. Watson is like Howard Stark, his father. It's really actually a pretty good analogy. I mean, you think about the moonshots that we're talking about today, the self-driving cars, all super cool stuff. Well, when T.J. Watson was running IBM, we did the actual moonshot. We actually worked on the moonshot to the moon. So we did some amazing things in those days, and it's in honor of him that we call it Watson. But the downside of calling it Watson is that it gives you this impression that there's this room of computers somewhere, and it's a singular mind, and that's not really correct. And it's important for you to know that if you're going to work with it, because it's not an it. It's a movement. It's a way of doing things. And when I think of it as a bag full of Legos. In fact, I'm going to show you at the end of this the bag full of Legos that you can use to make your own Lego spaceships. We've built things like Oncology Advisor and things that I just showed you. The real interesting question I have is, what are you going to build with it? And I'm going to show you those Legos today. So Watson isn't a single thing. It's a whole bunch of things running on all sorts of different computers in the cloud and as services that you can access for free today. Actually, I'm going to show you that right now. So if you go to bluemix.net, you'll see the current set of Watson technologies in our catalog that you can use today. So for example, two of my favorites are Personality Insights and Concept Insights. Just like last weekend, some buddies of mine and I were fooling around with Concept Insights and came up with a whole new startup idea. So they're very inspiring because they're very specific, very clean very clean APIs, and you can just use them. So we started fooling around with it, and I'll show you what a friend of mine built with Personality Insights in like 3 hours. So he built this application on Bluemix, and he said, wouldn't it be cool for my friends at Alibris if I were to use Personality Insights, which effectively takes some deep research that we did around neurolinguistic psychology, psycholinguistic analysis, and allow people to put in all of like their tweets and their blogs, and then generate effectively a vector, a set of 47 numbers that indicate what their personality profile is according to psycholinguistic analysis. Now that's fine, that's very good academic work, but what could you do with it that's fun? Well, what if I put all of the authors that I know about into that system, generate that vector, then do matrix math to say what authors are most like other authors, personality-wise, according to Watson. So he did. And in 3 hours, he's got like here, let's say, what's Barack Obama's, what's he like? So here's his writing style. He's an extrovert. He's got high degree of agreeableness, conscientiousness, neuroticism, and openness. And not to get into, and there's 47 of these, and he just presented these 5. That's cool. And we won't argue whether or not these are right or not. What's really interesting is comparing them to other people. So, I didn't know that was going to happen. So, I'm going to YouTube that. That's awesome. Black Elk, Jack Kerouac, Anais Nin. And all he wanted to do, in fact, which was funny, is get people intrigued enough to say, Why is that? And keep them on the website for longer. Because he knows that if people stay on this website for longer than 10 seconds, they have a much higher likelihood of buying a book. Right? So, so you can buy Sarah Palin's book by looking up Barack Obama. I'm not sure he'd be happy about that. Isn't that cool? So, I mean, he did that in 3 hours. Any of you could have done this. It's really simple. I mean, I'm a terrible programmer now, and I could have done it. And you know, my programming skills aren't what they used to be. So I'm actually working on making that better. I've been doing a lot of programming education lately on Udemy. So that's something you can do. So as I said, I like thinking of Watson as a bag full of Legos. And here's our bag. We got 50 of these widgets coming. Another one is visual recognition. Now, there's some other folks that have been famously showing you visual recognition. I have to say, having seen the back end of our visual recognition system, it's pretty exciting. Can I get it up? Yeah, there it is. So the upside of this is that the algorithms and the systems here are probably best of breed. The downside is that we aren't allowed to use that big Stanford visual database of images to train because of copyright. We're really, as IBM, we're really careful about copyright, and we can't use it. So so this particular demo isn't trained on that. It's just fairly limited, but it does find the salient objects and generate a mapping of the concepts that are related to those objects, and this is all untrained, or this is not supervised learning. So that's pretty cool. And the next set of stuff is even cooler because it does it on video. So I just saw some of the researchers in Almaden, just a few miles away from here, some of the best people on this in the world. And I've worked with some of the, I mean, I have a friend at Carnegie Mellon, Eric Jing, who's one of the best people in the world on this subject, and his mentor works at Almaden, or one of his mentors works at Almaden. So when I said, hey, I worked with Eric Jing, she said, oh yeah, I love that guy. He used to work with me. He was my intern. And I'm like, oh, cool. So like the mother of the father of machine learning for vision works for us. And she's been working on this cool thing where Watson is picking up myocardial infarction indicators in video of sonogram video of the heart, which is really hard to pick up on. It's really hard to see. And so, I mean, it's amazing work. So being able to do that, that's another, this is here. I mean, you can actually use this for free today. You can fool with it. The APIs are right there exposed for you. Let me show you one more. Concept Insights, I think, is my personal favorite. And I've got like a bunch of startup ideas just jump out at me when I think of what I could do with Concept Insights. So what Concept Insights does is create a knowledge graph based on your input. So say you're writing a term paper, and you put that term paper into Concept Insights. Watson's natural language capability, understanding what, I can't get this, the subsystem that runs this isn't up right now, so I wanted to show you this thing called X-Ray, which visualized what Watson does with your language and how it understands the parts of speech, and that up is that way, and that up yours means something different, and houses burn up while they burn down. You know, these kinds of linguistic anomalies, Watson takes care of all of that based on its ability to parse language. And so it parses language, finds all of the actual salient concepts that you've written about in your term paper, and then relates it and creates, imagine like an n-dimensional snowflake all around your term paper with all the related concepts that you might never have even thought of putting words to. So let's say you're a monoclonal antibody researcher. It just happens that if you look at, when Watson looked at like concept like monoclonal antibodies and looks at Wikipedia and other content from the web, that there's a that it's highly co-occurrent with dendrimers, which is a material science concept. If you're working on monoclonals, you never would have thought to write about dendrimers. But now you've got this concept expansion that says, hey, monoclonal work related to dendrimer work, related to dimers, related to dielectric materials. What insights could you get from that if you had this sphere around your actual paper of concepts that are orthogonal to what you were actually writing about? You could, when I was running a consortium of researchers in Australia, we were always feeling like we just didn't know what we didn't know. We were missing something. Well, this subsystem can actually help you not miss it. So in this case, if I put in quantum physics, right, I put in quantum physics, this is showing you all of IBM's researchers. This was probably ill-advised. We have all of our researchers. Don't actually hire these people away from me, please. These are all of IBM's researchers and their bios, where you're not only getting the researchers that have quantum mechanics or quantum physics in their bio, but but concepts that are 1 or 2 degrees of separation on a graph out from that. So you might find someone that you wouldn't have found just by a keyword search. I think it's really cool. And again, free. You can use it right now. We could go afterwards and write some code. I'll show you one last thing that we did with it. So this is our big Lego spaceship that we built with these Legos. Whoops. Hold on. I hope I get to cook with you. Hold on. Well, rats. I think I can't show you this from the beginning, but I will tell you about it. So effectively, what Watson and Bon Appetit teamed up, and we parsed all of Bon Appetit's previous recipes. And then, now that we've gone commercial with this, it's making it hard for me to do it. But when it was a research project, I just went in. We took all of the Bon Appetit recipes and fed it a lot of literature about interactions of different food ingredients. And now you can put in all of the, like asparagus and fennel and whatever you want to put in, and a type of dish, and it will generate a statistically very unlikely to have ever been seen before recipe. And almost always is delicious when you make it. So go to Bon Appetit and try that. It's really fun, and people love it. And we actually just published a cookbook of recipes that Watson came up with that world chefs have actually then prepared and found to be fantastic. I was at an event with Chef Watson in New York a few months ago, and Watson had made 7 martinis. And these, I'm not a big martini fan to begin with, and these martinis looked terrible. They had pieces of fish in them, and one had a little piece of steak in them, and I'm like, this is disgusting. But when I drank it, I was like, oh my gosh, that's the best thing I've ever tasted. And so that was, again, just something that we did with these subsystems that we're starting to publish for you guys to do stuff with. And what's exciting for me to be here is that a lot of times when I talk to busy researchers or busy startup executives or people at other companies, they're already so deep into what they're already doing that they're like, oh, that's pretty cool, and they don't do anything with it. But based on what I've seen you guys been doing, I have high confidence that people are going to walk out of this room and build some amazing stuff on these Legos, and I can't wait to see it. So I'll stop there. Thank you. Oh, you need this? Oh, got it.
So I think we have time for around 5 questions or so. Do you believe artificial intelligence can be a threat to humanity?
Is this working? No, I don't. It's funny. I write science fiction, and in fact, Daniel Wilson. Anybody read Robocalypse? Yeah, yeah. One of my favorite novels, and he really makes a big deal out of the robot uprising, and he's a great writer. And yeah, we both actually have the same agent, so I've talked to him before about this stuff, and it makes for great fiction. But when you actually get down into it, it's just statistics. It's just math. And no, I don't think that we're going to have AI take over the world. I really don't. At least not for a really long time. This stuff is useful. It can vastly expand what you can do to solve problems, but it's still it's computing resources extending what humans want to do. What it doesn't do is form intent. And if you think about it, I mean, forming intentions are hard enough for humans. Computers still don't have a way of generating intent endemically. And until that happens, I think we're fine.
Okay. Who is IBM's main competitor in this field?
Well, like a lot of early research, it's not so much about competitors yet as it is about co-opetition maybe, but mostly about collaboration. I mean, my first job at IBM was kind of making Java safe for the world back in the 90s. And what was great about that experience was that we had just this cadre of people all around us who were not just IBMers. They were researchers and developers from companies all over the place. Sun, Oracle, Apple. So we're in a collaborative mode right now with this stuff. So there's not really a proper competitor yet.
Okay. Do you think supercomputers like Watson can overtake humans in fields like the medical field?
Well, I think as I showed, it's really about the reason. You would never want. It's like GPS for the doctor in our case, right? So it's not like you don't let the GPS system drive the car. You still have the doctor. There's still intuition. There's still understanding the patient. There's empathy. There's all sorts of things. So Watson working together with doctors, we've shown it vastly improves the probability of a positive outcome for the patient. But you wouldn't want Watson flying solo.
Watson works on human terms and understands human language. Could this eventually make programming languages such as Java and Python obsolete?
I was about to say something catty about Java that I won't say. Is anybody still writing in Java? I helped bring Java to you. I'm sorry. I mean, I think that it's already getting to the point. It's not so much the cognitive computing itself is going to make programming languages obsolete. It's more that we're taking programming to a level where there's all sorts of things that are coming together where programming languages are just less obtuse and much easier to write and more language oriented. I was actually an English major in college, and then I got my engineering skills I acquired them along the way, and at Berkeley I did do a bunch of that stuff, but I didn't graduate in an engineering degree. I graduated in English, and people say, well, what language do you like to write in? And I'm like, the best programming language of all, English. And it is true. In fact, I'll tell you this story. We just hired this amazing woman who was an English major, graduated from UC Colorado in June, went to Galvanize, which is kind of like a finishing school for engineers, and became a full stack developer. 6-8 months later, we hired her onto the hottest development team in IBM right now, called the Blue Mix Garage in San Francisco, and she is tearing it up. She is the best. I just love working with her on interesting problems for two reasons. One, she's a good engineer. She's been pair programming with the best developers in the world for months and months. She's acquired all of these really nuanced insights and skills in engineering. But as a liberal arts major, she also really has a creative mind about what problems to work on. So she not only knows what to write or how to write. She also knows what to write. She's a good finder of problems, not just a good solver of problems. And that's a skill.
Okay, last question. Could you elaborate on Deep Blue's algorithm to defeat Kasparov? Is it similar to that used for Jeopardy?
Great question. And I don't think I can do it justice on stage here, but if you want to grab me after this, then I'm happy to talk more about it. Very different algorithms, right? So Deep Blue was, as it was described, is about deep computing. So it was really doing conditionals to an nth degree, right? We're talking about, at that time, we'd gotten computing to a point where you could brute force your way through chess. And Jeopardy was completely different. Jeopardy was completely different. We're talking about unstructured data. You could not do predictive analytics on it. It had to be dealt with in an entirely different way. It had to be about inferences and evidence-based reasoning that completely transcends what you'd see in Deep Blue and in chess. Chess was still a definable set of, it's a discrete number of rules that have a huge progression of different variables that come off of, or different pathways that come off of each decision, but it's still the same discrete set of rules. You don't have that with Jeopardy. I'll give you an example, my favorite one, the Lincoln category. The question that was asked in the competition was, Seward has submitted this to me 3 times, and by God, this time I'm going to accept it. And your typical junior high school student might answer a friend request because it's, he submitted to me a friend request. Not, necessarily realizing that Lincoln didn't know what Facebook was. Watson was able to interpret both, basically within 3 seconds, interrogated 200 million pages of text, 60 million documents, with no links in them, no hrefs, right? All just pure text language. Interrogated those documents, found evidence about who was Seward. Seward, well, high probability that we're talking about Seward, the Secretary of State of Lincoln, that Lincoln lived in the 1800s, that Seward, there's histories about Seward submitting resignation letters to, it's a resignation letter. And he got it right. That's, combining, that's 350 algorithms working together on 200 million pages of text in under 3 seconds, generating a confidence score about how confident it was about the answer, buzzing in and winning the question. And that was cool. It took 80 megawatts of power and a computing system the size of half of this stage to do that work. The challenge since then has been turning all of that into stuff that can run on pizza boxes and LPARs in a cloud infrastructure that's affordable enough for us to give it to you to do stuff with. And that's what we've done since then.
Okay, thank you so much for coming today and enlightening us about this project.